Kumar, lower down your arms. Okay. In the module number one, so you're going to study about one of the basic device which you are going to use in the communication system. We call it as a PN junction. You'll be studying about what is the equivalent circuit of the diode. And there is one more important diode what you are going to study. It is nothing but a Zener diode, and applications of this Zener diodes we will be working as a voltage regulator. Along with that, you will be studying about rectifiers, and in the rectifiers, there are two types of rectifiers are there. That is a half wave rectifiers and a full wave rectifiers. And there is a modifications for this half wave rectifier and full wave rectifier. We have come up with one more rectifiers. We call it as a grid wave rectifier and a capacitive circuit. So apart from that, what we will be doing is we will be studying some applications of these diodes. So like photodiode, that is a light emitting diodes we will be studying, and what you mean by photocoupler. Okay, and some of the voltage regulators which will be used in the general implementation of some any projects. We will be looking all those concepts in the module number one. Okay, so can anybody tell me what you mean by rectifiers? Yes, can anybody tell me what you mean by rectifiers? Anyone? What do you mean by a diode?
What's AC to DC?
It's a
It's a device that converts AC current to AC to DC.
yes, it's a device which converts AC to DC. Yes, very good. So basically, what we do is we want to convert the given AC current to DC current. So why? Because most of the applications, whatever we are going to run in our home appliances, they work on the DC current. Okay, so therefore, it is necessary for us to convert the AC signal to DC signal. So therefore, we use a circuit called as a rectifiers. Okay, so how we are going to use this? What you mean by half wave rectifier and what you mean by full wave rectifiers? We will be seeing. And yes, what do you mean by a diode? Can anybody tell me what you mean by a diode? What do you mean by diode? Yes, anyone? What do you mean by diode? Have you studied this in your basics in your second PUC?
Sir, it
Uh,
regulates current, sir, in one direction, in only one direction, sir.
it will make current to flow in only one direction. Is very good. And what do you mean by insulators and what do you mean by conductors?
Sir, insulators are the substances that doesn't allow the electric current to pass through them. So conductors are those the substances which allows the current to pass through them.
Yes, very good, Nitin. What do you mean by semiconductors then?
Sir, which is partially conductible substances. So
Yes. What
it
do you mean
depends on
by
temperature and other factors.
yes? Very good, Nitin. What do you mean by valency band? Can anybody tell me what do you mean by valency band, conduction band? Anyone you know remember these concepts? Yes, anyone? What do you mean by conduction band, valency band? Anyone? See, when we say that, when is it possible for electric flow to be happen? If I say that, okay, let's say a metal. So why metal exhibits a conductivity? Because of what factor the metal exhibits conductivity?
Sir, due to flow of electrons, sir.
Yes, very good. Due to flow of electrons. So flow of electrons is due to flow of free electrons. The conductivity will be exerted or it will be exhibited by the metals. Okay. So generally, when I take an atom, so this atom will be compromising in terms of 11 different bands. Okay. So if an element or if an atom exhibits free electrons means then it will be present. Those free electrons will be present in a conduction band. Okay, and you know that any atom it will be consisting of some bands, that is nothing but first band, second band and third band. So in the first band we will be having 2 electrons, and in the second band we will be having 8 electrons, and in the third band we will be having a 2 power 3, that is nothing but 16 electrons we will be having. So the outermost region of an atom we call it as a valency band. So now if I give some excitation to those bands, that is outermost band, what happens is the electrons will move for the higher band. So means what? From the valence band, they will move to the next band, and that band we call it as a conduction band. So in the conduction band, what happens is the electrons are free and they can able to move. The electrons are free and they can able to move. So therefore, because of that few phenomena, so the metals or any material will exhibit a conductivity. Okay, so therefore, so what we are supposed to do is, if you want to exhibit any electrical conductivity means, then an atom exhibits a free electrons. So what do you mean by free electrons? The atoms which are there in the conducting band, we call it as a free electrons. Okay, so to start with this basics, so generally what we will be having is, we will be having a three types of materials based upon the electrical properties. So the first one we call it as a metals. So that is nothing but the flow of electrons will be more. So these are the majority charge carriers. Those are the majority charge carriers in the conduction band, that is conductor. The second one we call it as a insulators. So insulators are the materials. So they will not pass any electrical signal passes within them. So we call it as a insulators. There is one more type of material. We call it as intermediate between the conductors and insulators. And those materials we call it as a semiconductors. Okay. So these semiconductors, when they're at the room temperature, they will not exhibit any electricity. But if we apply some external force to them, let's say by increasing the temperature or by providing some conductivity, we can increase the conductivity of the such material. So such a materials we are going to call it as a semiconductors. Okay. So generally what we are going to discuss over here is, so in the module number 1, so we will mainly concentrating on these semiconductors. So what do you mean by semiconductors? How we can make use of these semiconductors in the implementation of electrical circuits, we will be checking. Okay, so in this semiconductors, so generally there are two types of semiconductors are classified. One we call it as a intrinsic semiconductors, and second one we call it as a extrinsic semiconductors. So what do you mean by intrinsic semiconductors is, so these semiconductors we call it as a pure semiconductors. Okay, so these semiconductors we call it as a pure semiconductors. So if the room temperature, just if the room temperature increases means, then the conductivity of such material will increases. So therefore such a material we call it as a intrinsic semiconductor. So means what? We are not adding any other external entity within this material. Still they exhibit some conductivity. How? By increasing the temperature around surrounding the environment. So therefore, such a type of materials we call it as a intrinsic semiconductors. Okay, it is also called as a pure semiconductors. So the second one, what we can do for these semiconductors, we can increase the conductivity by adding some impurities, by adding some elements, and those elements we call it as the impurities. So by adding some elements to the semiconductors, we can possible to increase the conductivity. So such a elements or such a semiconductors we call it as a extrinsic semiconductors. So as the name suggests, extrinsic means we are adding some external entity to increase the conductivity. So therefore we call it as a extrinsic semiconductors. Okay, and the impurities what we are adding to the semiconductors, so we call it as a doping. The process of adding the impurities to the element we call it as a doping elements. Okay, and these extrinsic semiconductors widely used in the electronic circuit implementation. So because of their wider applicabilities. Okay, and so in this module what we are going to do is, so the extensive analysis of these extrinsic semiconductors will be studied. Okay, so the first thing what we are going to do is, we will be creating or we will be modeling these extrinsic semiconductors in terms of two material. Okay, so the first material we call it as a N-type material, and the second material we call it as a P-type material. Okay, so means what? So the element what we are going to add for the semiconductor, so if it exhibits a free electrons for the semiconductor, the elements what we are adding, so if it exhibits a free electron means, so such a type of adding the material to the semiconductor, or such a type of creating the elements, we call it as a n-type semiconductors. So in the n-type semiconductors, there will be more free electrons will be there to pass the conductivity or to carry the current among themselves. Okay, so how we can create this n-type material is, so by adding a pentavalent impurities atoms, by adding a pentavalent impurities atom. So why we need to add pentavalent impurities is because, so if you see the conduction band of a silicon, if you see the conduction band of a silicon, so at the outermost region there are four electrons are there. There are four electrons are there. So for these four electrons, if I add an pentavalent impurities, if I add an pentavalent impurity, what happens is this. So the four electrons, whatever it is there, right? So they will form a covalent bond to with this. The one more left will be there, and this we call it as a free electron. Okay, so this free electron is responsible for the movement of electricity. So such a type of material we call it as a n-type material. So in n-type material, the majority charge carriers will be electrons. So what are the pentavalent impurities, you can ask me. So there are the different pentavalent impurities we have. So from the table, that is nothing but arsenic we have, so antimony we have, and phosphorus we have. So if we have these pentavalent impurities for the semiconductors, then the conductivity of the semiconductors will be increased, and the majority of the carriers to carry the electricity will be electrons. So therefore they will be called as a n-type material. Okay, so there is one more type of material what we can create from this extrinsic semiconductor is p-type material. Okay, we can create a p-type material. So means what happens is, so if I add an element outermost region, so if it has a three electrons, means then these three electrons will make a covalent band with the remaining three electrons of the silicon, whereas the last electrons will be left. So means what, a positive ion will be created at the semiconductors. So such a type of material we call it as a p electron. So in the p electron, what we created is a hole will be created, means a positive charge hole will be created, and these positive charge holes are the majority charge carriers in the p-type material. Okay, so you can see here the p-type semiconductor and the n-type semiconductors. So you can see a electron is the majority charge carriers in the n-type element, whereas in the case of p-type semiconductor, the holes are the majority charge carriers. So you can see we have a negative acceptors ions is there, so the negative acceptor ions is there, whereas in the case of n-type semiconductor, there is a positive donor element is there, So this is how we are going to represent the two types of materials in the case of semiconductors. Okay, so the first we call it as a p-type material, and the second we call it as a n-type material. So what you need to remember over here is, semiconductors are nothing but they fall under the region of conductors and insulator. So if you excite or if you give some external entity to them, means then the conductivity can be increased. So there are two types of semiconductors are there. One we call it as an intrinsic semiconductor, and one more we call as an extrinsic semiconductor. Intrinsic semiconductors are nothing but these are the pure semiconductors. If in the room temperature itself, the conductivity can be increased. So such a type of material we call it as an intrinsic semiconductor. Whereas there is another type of materials what are there. So if we add some impurities to the semiconductor, we can increase the electricity or conductivity among them. So such a type of material we call it as either n-type material or other p-type material. So based upon how we add the impurities, so we can get n-type material and the p-type material. In n-type material, the majority charge carriers will be electrons, whereas in the case of p-type material, the majority charge carriers will be holes. Is that clear to everyone, this one? Hello?
Yes, sir.
Yes, sir.
Okay.
Clear.
Okay. So next what we do is, so we are going to make use of this n-type material and p-type material to form a device, and that device we call it as a diode. Okay, so diode is basically, it is nothing but it is a assembly of one p-type material. It is an assembly of one p-type material and one n-type material. It is assembly of one p-type material and n-type material. So this device we call it as a diode. This device we call it as a diode. Okay, so what do you mean by since we are sandwiching, that is p and n assembly, so therefore we call it as a pn junction diode. Therefore we call it as a pn junction diode. Okay, so you can see here the pn junction diode. Okay, so now you can see the p-type silicon. So we have created one terminal, and for the n-type silicon we have created one more terminal. So for these terminals we are going to create, or we are going to give the excitation. For this terminal we are going to give the excitation, or where we are going to feed the input. Okay, and generally the diode symbol will be written in this manner. Generally the diode symbol will be written in this manner. Okay, so the diode symbol will be written in this manner. Okay, so the positive terminal, see this we call it as a positive terminal, and this we call it as a negative terminal, and the positive we call it as a anode, the positive we call it as a anode, and the negative we call it as a cathode. The negative terminal we call it as a cathode. It is a two terminal device. It is a two terminal device. Okay, so this is how we can create a PN junction diode. Okay, so in the PN junction diode, so there are different types of diodes are there. So I request everyone, please make a note of this diagram, everyone. Before we go for the next one, request everyone, please make a note of this diode symbol. Yes, please. Once it is over, you should inform me so that we will go for the next one.
Excuse me, sir.
Yes, tell me, Pushkar.
So for the internals, this module will come, sir. Also come. Whole module.
Yes, it is. Yes, it is there, Pushkar.
Whole module, sir.
Oh, not whole module. I will tell you. Means some important concept. Two concepts will be coming. One PN junction diode will be there, and one more rectifier is there. Only those two concepts will be coming. That's all.
Okay, sir.
Okay, so we will concentrate only those two concepts. The remaining thing we will take up after the internals. Okay, don't worry. Okay. Now, can anybody tell me what are the applications of the diode? If you know anyone, what are the applications where we can use this diode? So already Manish has told it is a one way of transmitting the electricity. Yes, with the use of that we can create some applications, or we can use this diode in some applications. Can anybody tell me where? Is anyone?
Sir, in laser, sir.
How laser? How it can be used in laser, Manish?
Sir, in semiconductor laser, sir.
In semiconductor lasers. Okay. Yes, of course, we will be using the semiconductors in a laser. See what I am trying to say this. See, we can use this PN junction diode, or we can use this diode as a switch. We can use this diode as a switch. Okay. So since it passes the electricity from positive to negative conventionally, so if I want to pass any electricity means, then I can use like a switch. Okay, so if it is on means the current will flows across here. If it is off means what happens is this will be open circuited, means that there will be no current flows over here is, so it will be off state. Okay, so we can create, or we can use this diode as two modes. One we call it as a on mode, and one more is called as a off mode. On mode means diode will be conducting, so the current will passes over here. In the off mode, what happens is there will be no connection will be there from P to N, or the flow of electrons will not be there from P to N. So therefore it is called as a off mode. Okay, so we will see how actually it is doing all these things. Okay. Have you taken on this one diagram? PN junction diode. Is anyone?
Yes, sir.
Okay. Okay. So depending upon the operating principle or depending upon the how we apply the voltages and currents to the terminals what we have created. So we have created two terminals, right? So one we call it as a P and one we call it as a N. So how we apply the voltages, to these terminal. So we are going to divide these diodes into three important categories. So the first we call it as a low current diodes, and the second we call it as a medium current diodes, and the third one we call it as a high current diodes, or it is also called as a power diodes. Okay, so now we can see here the if the forward current capacity, so means what, the current which is flowing through this PN junction, if it is up to 100 milliseconds, we call it as a low current diodes. Or if it is able to withstand, up to 75 volts across the reverse voltage means, then we call it as a low current diode. Okay, so second one is medium current diode. So what do you mean by medium current diode is, so if it can forward the current or the rate of flow of current, if it can withstand up to 400 milliseconds, so means what, greater than 100 millisecond and less than 400 milliseconds means, then we call it as a medium current diodes. Or else if it is able to withstand the voltage, if it is voltage whatever we are going to apply across these two terminal voltage, if it is able to withstand across the reverse bias up to 200 volts means, we call it as a medium current diode. The third one is power diodes. Okay, so what do you mean by power diodes? So here, so we will not concentrate about the current capability, means the current capability of the power diodes will be more, but whereas the reverse voltage or the voltage with which the diodes will operate will be in terms of hundreds, several hundreds. It may be 100 watts, 100 kilowatts, like that it will be there. So means if the current voltage capacity of the diode, if it is larger than 200 volts means, then we call it as a high power, that is a high current diodes, or we call it as a power diodes. You can ask me, so where and all we can use these low current diodes? So in the application, so whatever we have studied, right, digital circuits implementation. So if you want to create an on and switch means, then we can use this low current diodes. So or if whatever I told you, we are going to use it in rectifiers. So if you have a rectifiers, if the input supply is 5 volts means, then we can use this current that is low current diodes. The next one is medium current diodes. So the medium current diodes can be used in our home appliances. So if you want to have a on and off switches, so because the power supply what we are getting, it is a AC supply from the home, so it will be 220 volts. So these 220 volts can able to operate or withstand the diodes which are there in the medium current diodes. And in the higher bulky industries where they will be operating more on some means higher voltages or some drivers or some motors, if you want to run it means, in such applications we will be using a power diodes. Okay, and we will now see, so how, what is the basic operation of this PN junction, so what are the characteristics it will be exhibited. Okay, so we will be seeing it now. So that is nothing but PN junction. Okay, so now you can see here, so how the PN junction is formed is, so PN junction is formed for the single layer, so if you add the first some part of it to the impurities, that is nothing but pentavalent impurities, if you add means it will become a N type. Pentavalent impurities, if you add, it will become a N type. If you add trivalent impurities means, it will become a P type. Okay, so means what, on the one side you are going to add the acceptor impurities, and the other side you will be adding a donor impurities, so that you are going to create a on a single layer. So you will be taking a single semiconductor material, the first part you will be adding some trivalent impurities to make it as a P element, that is a P type semiconductor, and you'll be adding a pentavalent impurities like a phosphorus and all, so that you'll be creating a N type material. So when you create a element like this, so such a elements we are going to call it as a PN junction. Okay, so now you can see here the PN junction. Okay, so the p type we call it as a acceptor ions will be there. Okay, that is nothing but there we'll call it as a positively charged holes we are going to call it as, and the right side we call it as a donor ions. The right side we call it as a donor ions, and we call it as a free electrons. Okay, and since you can see here, since the n type has high concentration of electrons and p type has a high concentration of holes, since we have a majority of the holes in the p-type material, so the high concentration of holes will be there in the p-type material, and high concentration of electrons will be there in the n-type material. Okay, so when I create a means material like this, so this is how you will be creating, or this is how it will look like. Okay, so now you can see here, so in the p type, as I told you, the majority of the movement will take place because of the holes. Okay, so now what happens is, along with the holes, there will be some minority charge carriers will also be there. Some free electrons will also be there. Okay, so these we call it as a minority charge carriers. This we call it as a minority charge carriers. So in this P junction, okay, so the majority will be hole, minority will be some electrons, minority will some electrons. Okay, and here you can see in this, there are majority will be free electrons in the n-type material. In the n-type material, the majority will be free electrons, whereas the minority will be some holes. Whereas the minority will be some holes. Okay, so now what happens is, you can see here, when you sandwich or when you create such a type of material. Okay, so now what happens is, the positively charged holes, whatever are they, right? So they will be attracted to these acceptors or donor elements which are there over here in the junction of over here. Is what happens is, in this junction where the p and n junction are combining, right? So in this junction what happens is, so because the distance between over this region, if it is very small, what happens is, the holes or the ions what are there, right? So they will try to attract over here, and similarly the electrons what are there in this region, they will try to attract it over here. Okay, so therefore what they will become is, they will try to occupy this position, or they will come over here, and these positive holes will try to attract over here. So therefore there will be, what happens is, there will be a accumulation of positively charged ions and a negatively charged ions will be accumulated, and those combinations here, what happens is, they will create some type of channel will be created. They will be created, some type of channels will be created. Okay, so how it will be created? Because of the positive type holes, so because of the charges, because there are negative electrons are there, no, so they will come over and they will attract it towards this, they will be attracted towards this. So therefore what happens is, they will become a negatively charged immobile ions will become. Okay, so therefore we have represented, since it has consumed the electron, so therefore we call it as a negatively charged immobile ions. So similarly the electron, they will consume the positive atoms, so they will become a positively charged immobile ions will become. So now what happens is, there are two immobile ions are there, one is a negatively charged and one is a positively charged. So some bond will be created across the junction of this 2pn junction, and this bond or this region we call it as a depletion region. Okay, so what do you mean by depletion region? The depletion region is the region where a negatively charged immobile ions and a positively charged immobile ions will be accumulated at the cross section of the p-type and n-type material, and that region we call it as a depletion region. Okay, so that region we call it as a depletion region. Yes, any doubts is there in this? Anyone? Hello, any doubts?
No,
Shall we
sir.
go next? Shall we go next?
Yes, sir.
Okay, so now what happens is, okay, so you can see, so what is this region, or how it has been created, and what is the range of this region, if you see here, so the depletion region will be of the order of 1 into 10 power minus 6 meter. So means what? The width of this depletion region, we call it as a 1 into 10 power minus 6 region. Okay, so this we call it as a depletion region. So now we can see here, in between the immobile charges at the junction, there exists no charge carriers. Such a region is called as a depletion region, or it is also called as a space charge region. So here in this region, so there will be no any movable ions will be there. So therefore we call it as a immobile region. And here there will be no any free charge will be there, and such a region we call it as a depletion region, and also it is called as a free charge region. Okay, so now you can see here, on the n side you can see here, so this is n side. You can see on the n side it consisting of, and the n side of the depletion region, it consisting of the donor impurities atoms. So means what? The positively charged atoms will be accumulated, so therefore we call it as a donor impurities atoms. Okay, and here in the p type regions, so we will be having a negatively, that is a acceptor regions will be, atoms will be accumulated by losing the hole associated with them. Okay, because they will be lose the holes, so because of the negative attraction they will lose the hole and they will become a acceptor impurities. Okay, and because of this negative atom and because of this positive atom, there will be an electricity will be produced, or there will be a some force of barrier voltage will be created. Okay, so means what? Something like a bond will be created between this positive and negatively charged atom, and that bond or that voltage difference we call it as a junction barrier voltage. That region we call it as a junction barrier voltage. So means what? Some force of attraction has been created between these two layers, and that force of attraction we are going to represent in terms of voltage, and that we call it as a junction barrier voltage. Now you can see here, over here is, so the p type material and the n type material, so they have created some band over here. Okay, so this, it is a band what we have created, and this band or this type of region we are going to call it as a depletion region. Okay, so this is how it will be looking. So if I create an PN junction diode means, then you will be having a, one is a p type material and a n type material. So because of the positive holes ions will be attracted over here and the negative hole ions will be attracted over here, so there will be a create, means depletion will be, region will be created. This is when you create an PN junction diode. Okay, so this is what will happen in general. Okay, so now what we should do is, so when I apply some voltage, when I apply some alternate external voltage to it, what is the region for this, or how the electrons will behave, how the neutron holes will behave, that we need to understand. So the application of external voltage, we call it as a biasing. The application of voltage external entity to this PN junction, we call it as a biasing. We call it as a biasing. So biasing is nothing but applying a voltage, external voltage to the PN junction. We call it as a biasing. Okay, so there are different types of biasing. We call it as, one is called as a no biasing condition. So in no biasing condition, what we do is, there is no voltage will be across the PN junction. There will be no voltage will be across the PN junction. So such a condition we call it as a no bias condition. So if you do not apply any external voltage across this junction means, then they, because of this bond which has been created because of this depletion region, so they exhibit some voltage or a barrier voltage, and that barrier voltage will be in the order of from 0.3 volts to 0.7 volts, 0.3 volts to 0.7 volts, 0.7 volts will be there. Okay, so under an unbiased condition, so because of the attraction of these holes or immobile holes, because of this force of accumulation of the negative ions and the positive ions, okay, so what happens is, some voltage will be created or voltage difference will be created, and that potential barrier or the potential difference, voltage difference, it will be in the order of 0.3 volts on the 0.7 volts. So this condition we call it as a no bias condition. Are you able to understanding this one? Yes.
Yes, sir.
Okay.
Yes,
So
sir.
this we call it, yes, no bias condition means there is no external entity we will be applying for the diode. So the next one we call it as a forward bias PN junction. So what you mean by forward bias PN junction is that, so for the positive terminal, the positive end of the battery we are going to apply, and for the negative terminal, that is N type, we will be applying a negative terminal of the battery. So if you apply a voltage or if you bias your PN junction diode like this means, then we call it as a forward bias PN junction. Forward bias PN junction we will call it as. Okay. So what the applications of this and all, now we will see. Now what happens over here is, so when you apply a positive voltage for this PN junction, what happens is, now you can see holes are there. So positive voltage means what you are applying. So means what? Again the means the electrons will be coming over here. So means what? Conventionally the voltage, when you apply the voltage means the flow of electricity will flow from positive end to the negative terminal. Okay, so the negative terminal. So what happens is, you can see the positive applying to positive means they will repel each other. So means what? The holes will start to flow in this direction. And since you can see here, we are applying negative to negative, what happens is they will also free electrons. They will try to move in the opposite direction. They will try to move it in a opposite direction. So because if the voltage whatever you are applying, if it is greater than the barrier potential what you have created, greater than the barrier potential what you have created, if the input voltage is greater than this barrier voltage means, then this depletion region was there, right? So it will be vanishes, it will vanishes. So therefore the holes will move over here and the electrons will move over here. So therefore the current will flow across in this junction. Okay, so therefore in forward bias condition the PN junction will be in a conducting mode. The remaining things which is associated with forward bias condition, we will see it in the next class. Okay, so we will stop it over here only for the today's section, and the remaining thing we will see it in the next class. Okay, is that clear for this?
Yes, sir.
Yes, Pushkar, what do you mean by
Yes, sir.
yes, what do you mean by intrinsic semiconductor? Can anybody tell me?
So where the number of electrons is equal to number of holes, sir. It's a pure form.
Okay, very good. Yes. What do you mean by no bias condition? Is anyone apart from Pushkar? What do you mean by no bias condition?
So when there is no potential between the junctions, sir.
Yes, very good. What do you mean by conduction band? Others, what do you mean? Yes, Naveen.
So it is a threshold gap between the uh, the,
Yes,
the lower region to the upper region, so that low potential
yes.
to high potential.
Okay. See, conduction band is nothing but the difference between the free electrons what are there with the valency band. So that energy gap we call it as a conduction band. Okay. So now if the electricity has to be produced means the electrons has to be there in a conduction band or a valency band.
Conduction
Anyone?
band, sir.
Yes, it has to be in a conduction band. Okay. Yes, Nitin. Yes. Okay. So these are the things what we have studied in this class. So the remaining things and we will discuss in the next class. Okay. So thank you everyone for attending the classes. Once again, I'm requesting all the students, those who haven't taken the quiz, kindly take up the quiz now only. It will take hardly 10 to 15 minutes. Is that clear?
Yes, sir.
Yes, sir.
Okay. Okay. Thank you everyone for attending the classes. Thank you all. Okay. Thank you.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you,
Thank you.
sir.
Excuse me, sir.
Yes, tell me, Rasul.
Sir, I have taken up the quiz.
Okay, Rasul. Thank you. Okay.
Okay, thank you, sir.
Yes, Akram, Nikhil, you can exit from the meeting. Nishant, Pratham, Sandeep Yadav.